Hello and welcome to another video tutorial on how to use MATLAB. Today we'll cover the topic of polynomials and in this context also the publish function. And for this we also need the Cellmode. So to demonstrate, I'll create a new M file and name it polynomial. And as you may notice, I am in this folder here, so I created a new folder called Polynomials, and in this one I created the M file. To open this, we'll simply double click and then the editor opens, which I can dock with this arrow. And imagine we have a polynomial, so any kind of polynomials. Just for an example, I'll type it in as a comment, so that you can see how it would look like. So let's say polynomial p1 of x equals x to the power of 3 minus 3x to the power of 2 minus x plus 3. When we deal with polynomials in MATLAB, it is sufficient to write the coefficients into a vector. So in this case, it would be p1 written as a vector. And the first coefficient is a 1 because we have x to the power of 3. So 1, the next coefficient is minus 3, the next one is minus 1 and plus 3. And this is how you get a polynomial in MATLAB. So let's take another example. So or polynomial 2 would be maybe something simpler. Let's say x to the power of 2 minus 4. And written in the vector mode, it is, don't forget the semicolon, 1 and minus 4. And now if you want to find out values at a certain position of the polynomial, then we do it as the following. So we, for example, want to find out what the value would be if x equals 1 in our first polynomial. So this means we define ourselves a variable named x equals 1 and a second one named y1, which then is the function polyval, named for polynomial value, and assign the values, first the p1 polynomial and then the position x, which we defined as 1. So we can comment here just as a reminder. So to be assigned is the polynomial first and then the position. So and if we run this, then we see that the position at x equals 1 is y1 equals 0. So in this polynomial will result in 0 here. And we can also set a 2 for x, then the y value would be minus 3, and so on. And right here I want to introduce the Cellmode. So for this we can see how these buttons work. So if I press the plus button, for example, then MATLAB sets the value of x to 4, so 1 higher. And we can just try again, and also MATLAB will run the script automatically. So we can change the x value further and further, and we can see where the graph is going. So it goes higher and higher into direction of positive infinity. And if we go the other way, so let's go down for 0 and minus 1, it's 0. So the direction is also negative infinity. So let's set the value back to 1 and see how our second polynomial looks like. So to see this, I'll type in y2 equals polyval of our second polynomial p2 and x. So and if we run this, we'll see that at the position 1, the y value is -3. And again, we can change our x value by increasing or decreasing it to see how the y values change. We can also multiply our x value with 1.1, or of course divide it by this value. Then our x will get smaller. So now I want to introduce you to the cell mode. So it also has to do with the bar we just used here. So this row of symbols is related to the cell mode. And so for example in MATLAB you can type in 2 percentage symbols to define a cell. And you already see that a help section is popping up, so you can read the help here. But I don't want to do this now because I first want to show you how it works. So in the first row I'm typing in 2 percentage symbols and name it polynomial. And then I'll create a second cell, also started with 2 percentage symbols. You can also see, so the first cell here has a certain background color different from the others. So you can see the distinction. And the second cell I'm gonna name definition. And in the next row I'll type in the definition. So due to the coefficients, a polynomial is uniquely determined and it is sufficient to write the coefficients into a vector. This is what is being said in these 2 lines. And in the next rows I'll just create the third cell, which I'm going to name example. So save. And while I'm saving, just pay attention to this window here, because when I press save, you see that the headlines of the cells have been displayed in this window. And also if I take away the colon and save again, you see that the colon is also gone. It is only displayed because this file here is selected, because see, if I unselect it, there's nothing shown, but if I click on the file, then it is shown again. And if I double click on a headline, so for example the example, then the cursor will automatically jump to each section, to each cell. And now back to our toolbar up here for the cells. So if I press this button, the highlighted cell will be executed. So if I press this, in this case it is really unspectacular because nothing will happen because we have nothing written there. In this cell the same. But in the third cell, so if I press this button, you can see that the command window changed. And this is a very good possibility to structure your code. So also it is useful especially with regard to larger projects, so you can have a better overview over your code. And also to change the values inside of a cell. So for example, I can add 2 percentage symbols here just to create a new cell. So this is a cell and this is the next one. And here also another cell. And then if I just execute this part here, then you see the output is just the polynomial 1. And now we can then change values inside of our polynomial. So for example, we put a 2 instead of the 1 here. And if we just execute this part, then you see how the 2 is in the output. So back to 1. And now I want to add more cells. So first of all, just add another one here with the headline of values at a certain position. And also we can add a normal comment below. So let's just say, for example, at the position x equals 1. And polynomial 1 of 1 equals what? So I'll add another cell in this line, but without a headline, just as in this line. So, and if I save this, then you see only the cells with a headline are displayed in this window. But with this button in the toolbar, if you press this, then you can see all the cells. So the ones with the headline are just named after them, and the ones without are just displayed with a number in order of their appearance. So now let's just create a table of values, and for this I'll create a new cell and name it table of values. And then for this I'll need a new x vector, which is running from -2 until, let's say, 4. And of course the y vector, which is defined as the polynomial values of our polynomial number 1, and the x vector. So we oppress the output with a semicolon. And now for the table, we also create a new variable. And in this, we are going to write the x and the y values. And if we run this, then you see the values listed up in the command window here. But it doesn't look good yet because those are row vectors. And so let's just change it to column vectors. And if we run this, then you see a nice table with all the y and the x values. So these are y values listed up. So this is how we can create tables. Now for the next section, I'll create another cell and name it graphical representation. And here we want to see how to plot the polynomial. So we already have the vectors x and y. So all we need to do is to enter plot x, y. So, and if we run this, then you see how our polynomial has been plotted. But it doesn't look really good yet because we defined our x vector with a default step size of 1. So from -2 to 4 with a step size of 1. So we can enter here, let's say, a step size of 0.1. And if we run this again, then you already see that the shape is much better. Of course, we can also adjust our plot now. So for this, we'll set a grid and also a title, let's say polynomial. And we need labels for our x and y axis. That's why I'm entering x label with an x and y label with a y. And if we run this, then you can see how the plot looks like now. In the next section, we'll just want to find out the zeros of our polynomial. So I'll add a new cell and name it finding zeros of our polynomial. So, and for this, we'll need a new variable named r, and we use the command roots for this. And inside, you just enter the polynomial p1. And if we run this now, the answer is written in the command window. So r is 3, -1, and 1. And as you can see, the roots of our function indeed are at 3, 1, and -1. And if we want to display the roots in our plot, then first we have to add a hold on after our plot function. And then I'll add a new section. And in this one, we have to plot the roots. so our variable r. And these are the x values, and for the y values, which are of course the 0 because we search for the zeros of the function. But you can also type in the polyval of our polynomial with the roots and display them as, let's say, stars in red. So if we run this, then you can see that at the zeros of our function, red stars have been added. But of course, because this part is always going to be 0, we can instead just type in 0. And if we run this, then you see that is the identical solution. Okay, so now you could ask, why did I do this all with the cells? Well, there's a small button on top of the toolbar, which is this one here. It says Publish Polynomial, and this one is just the same as if you click File and Publish Polynom. So what this does is, so if we click this, then MATLAB will automatically create a small help text from our code into this help file. So this help file is nothing else than a simple HTML file, as all the other help texts are just as well. And here you see the contents, so just all the things we wrote down. So for example, definition, example, with our example, and this is just the same we wrote into our code. Now I'll undock our editor so that we can see better how the file is structured. So we have here our definition, which is just written down in the help section. And then we have our example. We can still modify our example. A helpful thing would be to add 2 dollar signs before and after the equation. And then let's publish it again. And then you'll see our example has been formatted from text into a real equation. You can also change the format of text. So for example, here you could transform the section a vector into bold text, so, and just by putting it in stars. And if we publish this again, then you see that a vector has been set to bold. And here you see the first command we type in, which is then also published here. And this is only because we didn't add a colon to our code here. If we would do this, so let's type in a colon, then it would not appear. So also let's change the next equation to a real equation format and publish this again. So you see we don't have the first command anymore, and we have the second equation into equation format. Then the values at a certain position looks okay. So we'll keep that. Then we have our table of values, but I find that too long. So we are going to add a colon here, so it would not appear. And then the next thing, the graphical representation. A good thing is that the plot is published automatically into the HTML file. So this looks really good. And what we have next is our roots, and here's the roots which are added to the plot. And how does this look in our folder? So let's look here. Here's the M file. Right now the file extension is not shown, so I'm going to change this. So here, file extensions. So now you see this is an M file, and when we publish our code, then you see that a new folder called HTML has been created, and in this one you'll find the plots as PNGs and also the equations in PNG form. And these PNG files are then embedded into our HTML file. We can look at it in the HTML editor for a second. So let's open this with Notepad. And then we see first our doc type, then the HTML tag and the head tag. Then we have some metadata, and the style is set here with this command. So for example, which color H1 headings should have or H2. And here the body tag opens, so I can also unfold this. So here is where the code basically starts. So the code that we created ourselves just in this section. So this is here, and then this is the table of values, so this is all good. And you see that with the publish function we can simply transform M files to a certain other format, like the HTML file. And this HTML file can also be seen in a browser. I don't want to use the Internet Explorer, that's why I'll open Google Chrome. And let's see how the file looks like in the browser. So, first of all, you see the path. Here, the polynomial.html file and the folder polynomial. Then here is the complete file for this. So it's basically a whole documentation. And we can try to inspect the elements. So just mark this and select inspect element, and then we see that this here is a H1 heading. And here in the HTML file we can see how the H1 heading is defined, in which color and in which font size. And this right here is one of H2, and for H2 you can see that the color is set as the same, but the font size is medium instead of extra large. So that's why it's smaller. And this information is also given in this window here, so the color and font size. The last thing about this I wanted to show you is the update of our table of values. So we updated it already, but we have to publish it again, and then if we press the reload button in our browser, which refers to our HTML file, then you see that the update gives that we don't have the output of the table of values anymore. But besides publishing our code to HTML, there are also other possibilities for other formats. So we have here our HTML file, but if we press the button next to the publish button, so edit publish configurations for polynomial.m, if we select this, then another window opens, and you see here all the settings and possibilities for a publishment. And the most interesting part is the output settings, output file format, and here you can change from HTML to a lot of other formats. So for example XML, extended markup language, LaTeX, or doc. We also have PPT and PDF. And just now I want to export it to a PDF file. You see here that the selected folder is still the HTML folder. So let's publish this. The code is running through. And then you see here that a new PDF file has been added to our folder. And when we open it, you can see that it looks really similar to the HTML file, so everything that we wrote into our M file is just documented in this PDF. And this is also what I can recommend you, so you should always document your code, and also you should use the public function because it is a really nice way to keep records of your code, and this is important. And I can also recommend you to use the Cellmode also for debugging, so just debugging section by section. In this file it wasn't really that important, but if you have larger projects then it surely is useful. So that's it for today. I hope you did learn something, and see you next time.